So I welcome you to another video. And today we'll be looking at the zeros and the singularities of function. Now, the zeros and singularities of function, they literally mean the same thing, but there is a very slight variation between them. So stick to the end of this video to understand what the difference is between the zeros of a function and the singularities of a function. But before we move, let us look at the zeros of a function. The zeros of a function are all the values of x that makes a function to be equal to 0. The zeros of a function are the values of x that makes a function to be equal to what? 0. Now, the zeros of a function is not 0. The zeros of the function are the values of x that makes a function to be equal to 0. And it is also known as the roots of a function. So let's say we have a function x squared plus 3x plus 2. Let's say we have a function f of x, which is equal to x squared plus 3x plus 2. And we are asked to find the zeros of this function. In order to find the zeros of this function, we would have to find the values of x that will make this function to be equal to what? 0. Now, as you can see, we have a quadratic function here because the x has the highest power of 2. So it's a quadratic function. Now, then what we'll do next is to equate this function to be equal to 0, and then you solve for x. Since we are solving for x, there are various methods we can use to find the values of x when we have a quadratic function. We could use the factorization method, we use the completing the square method, and we could use the what? Formula method, which is your quadratic formula method. Excuse me. So, the first step, whenever you're finding the zeros of a function, equate the function to be equal to what? 0. Now we'll solve for x. To solve for x, we'll use the factorization method because it will be much faster. So this is what we call the sum of the roots, and this is what we call the product of the roots. Now, since this is the sum of the roots and this is the product of the roots, it means we need two numbers that when we multiply them, we'll get a positive 2. And when we sum them up, we'll get what? A positive 3. And those numbers will be what? Positive 1 and positive 2. Because positive 1 times positive 2 give me what? A positive 2. And positive 1 plus positive 2 give me what? A positive 3. So we'd have x squared plus x, because it is this 1x. So we'll not write 1x because it will not be proper. Plus 2x plus 2 equal to what? 0. So 2x, and then this your 2 will bring it down. Now, since there are 4, we can pair them up. What's common between these two here is x. So we have x plus 1 plus 2 bracket what? X plus 1 equal to 0. Now, since we have this, since both sides, these brackets are the same, we'll pick one of them. We'll have x plus 2 and what? X plus 1 equal to what? 0. Now, we'll have x plus 2 equal to 0, or x plus 1 equal to what? 0. So x will be equal to, once positive 2 crosses the equal to sign, becomes what? A negative 2. Or once positive 1 crosses the equal to sign, becomes what? A negative 1. And therefore, x will be equal to negative 2 or what? Negative 1. Now, the zeros of the function is not negative 2 or negative 1, but negative 2 and negative 1. So the zeros of this function is what? Negative 2 and what? Negative 1. Let us see. Let's confirm if this is true. Now, let us find f of negative 1 here. So if we find f of negative 1, you see that we have replaced the x with what? A negative 1. So anywhere we see x in the function, we replace it with what? Negative 1. So we'll have negative 1 squared plus 3 bracket negative 1 plus 2. Now we'll have this. Negative 1 squared is positive 1. Positive 3 times negative 1 will give me what? A negative 3 plus 2. Board so we add before subtracting. 1 plus 2 is what? 3. 3 minus 3 is equal to what? 0. And therefore, it is true that negative 1 is a 0 of this function. Negative 1 is a 0 of this function. Now, there's an easy trick to this. Whenever you have a quadratic function and you are looking for both the zeros of the function and also the singularities of the function, when you have a quadratic function of this type, or when you have a quadratic function and you already know the roots, that means the sum of the roots and the product of the roots. In this case, you have a positive 1 and positive 2. The zero of the function will be the opposite of the signs of those roots. So for this, it will be what? Negative 1, and for this it will be what? Negative 2. So instead of going through this, to be very fast, just know that you change the sign and that will be what? The zero of the function. As you can see, we have a negative 2 and we have what? A negative 1. Now, if given a rational function, when I say a rational function, I mean a function that is in form of what? Fraction. So if I have a function f of x equal to 1 all over x, so this would be a rational function. So given a rational function, let's say f of x, which is equal to p of x over q of x, the zero of this function is p of x. So p of x, or the values of x that makes p of x to be equal to 0, is the zero of the function. I repeat myself again. If we are given a rational function f of x, which is equal to p of x over q of x, the values of x that makes the function p of x to be equal to 0 is the zero of the function. This is what I mean. Let's assume I have 0 divided by 2. If you check this on your calculator, you will see it's equal to what? 0. 0 divided by 1,000 to equal to what? 0. So whenever the numerator is 0, the entire function becomes, or the entire thing becomes what? 0, regardless of what is in the denominator, as long as the denominator is not 0. So as long as the denominator is not 0, once the numerator is 0, the entire thing becomes 0. So what it means is, if you are given a rational function and you're asked to find the zero of that function, just look for the 0 of the numerator and the entire function becomes 0. So let's look at examples as regards to this. So now we have these examples to find the zeros of this function, only the zeros, not the singularities. So we're asked to find the zeros of this function. The first one, we can see we have a rational function. And don't forget, we just spoke about it, that when we have a rational function, the zero of the function is the values of x that makes what? The numerator to be equal to what? 0. So in this case, we don't need to bother about finding the zero of the numerator and finding the zero of the denominator. We just only look for the values of x that makes what? The numerator to be equal to what? 0. Now we'll apply it and see. So when we have this, to find this, so we are only looking for x squared plus 7x plus 12. We equate it to be equal to what? 0. Now we solve for x. To solve for x, don't forget, sum of the roots, product of the roots. So two numbers that when we multiply them, we get positive 12, and when we sum them up, we get what? A positive 7. So we'd have those numbers to be what? Positive 4 and what? Positive 3. Because positive 4 plus positive 3 will give me a positive 7, and positive 4 times positive 3 will give me what? Positive 12. We use our shortcut method now. This would be negative 4 and what? Negative 3. So these are the zeros of the function. Simple as this. So since these are the zeros of the function, we can find for f of negative 3. So f of negative 3 would be negative 3 squared plus 7 bracket negative 3 plus 12. Not only for the numerator, we are also doing it for the denominator. So we have negative 3 squared also, minus 5 minus negative 3 plus 6 equal to. So negative 3 squared is what? A positive 9. So we have a positive 9. Positive 7 times negative 3 would obviously give me what? A negative 21. And we'll have plus 12. Divided by this, we'll have 9 plus 15 plus 6. Because a negative 3 times a negative 5 times a negative 3 will give me a positive 15. And we'll have negative 3 squared is what? Positive 9. So if we come down here, negative 3 will be equal to 9 plus 12 will give me what? 21. So we'll have 21 minus 21 divided by 9 plus 6 plus 15, whatever value it will be. As long as the numerator is what? 0, the entire function becomes what? 0. And that's why we only find the 0 of the numerator, and the 0 of the denominator is what? Is not useful in this case. Except in a situation where the denominator will also give us what? 0, but in most cases it wouldn't. Most questions won't bring it in such format. So to always make sure that the numerator is what? 0. So for a rational function, always find these values of x that makes the numerator to be equal to what? 0. Let's move to the next question. For the next question, we have f of x is equal to cos of 2x. So we have a trigonometric function now in this case. As I always say, first thing you do is equate the function to be equal to what? 0. So we have cos of 2x equal to what? 0. Now we are solving for x. To solve for x, we divide both sides by 2. We divide both sides by 2, we would have that cos of x, 0 divided by 2 will be what? 0. To solve for x, we carry cos to the other side. We have x is equal to cos inverse of what? 0. Now, if you're with your calculator, I am with mine here. So if you're with your calculator and you find the cos inverse of 0 would have 90. Therefore, x will be equal to what? 90 degrees. Now, is this true that the 0 of this function is 90 degrees? Let us see. If we find that f of x, or let's find f of 90 degrees now in this case, meaning anywhere we see x, we replace it with 90. So we have cos of 2 bracket what? 90. 2 times 90 is 180. Cos of 180 is equal to 1. And therefore, this is not 0. So this is not true. What we forgot to do is this, that we divided both sides by 2 in the beginning. So we only found the 0 of cos of x. So what you do is, whatever answer you get, you divide it by what? 2. And therefore, the 0 is what? 45 degree. 45 degree is the 0 of the function and not 90 degree. Now, you could also add to this. To add to this, we'll go to our Cartesian plane. This is your cast. That means all sine, tan, and cos. This is theta. This is 180 minus theta. This is 180 plus theta. And this is 360 minus theta. So we'll have this to be 0 degrees, 90 degrees, 180 degrees, 270 degrees, and 360 degrees. Now, our theta is what? We solved our theta to be what? 90. Now, all angles or all trigonometric functions are positive here. That means cos, tan, and sine are positive here. So what you do is, since we are looking for cos, we'll go to the Cartesian plane where cos is positive. Now, what will we solve for? We solve for 360 minus what? 90. So 360 minus 90 is what? 270. So what we'll do next again, we'll say 270 divided by what? 2. Now, 270 divided by 2 will give me 135. And also 135 is also the 0 of the function. So you can find for f of 45 degree, also f of 135 degree, and you'll see that those will be the answer to this question. Now we are also asked to find the 0 of the function tan of x. So we'll follow the same procedure. Or better still, solve this and drop your answer for me in the comment section based on what you have learned from this. So just solve for this and drop your answer in the comment section. I would love to really hear from you guys. So let's move to the last question, which is h of x is equal to what? Now, this is not your sine, this is your hyperbolic sine of 2x. So it's a totally different trigonometric function from your sine. So this is your hyperbolic functions. So your hyperbolic sine of 2x will follow the same procedure also. So we'd have hyperbolic sine of what? 2x. We equate it to be equal to what? 0. Divide both sides also by 2. We divide both sides by 2, we have the hyperbolic sine of x is equal to 0 divided by 2 is what? 0. So x would be equal to what? The hyperbolic sine inverse of what? 0. Now, if you are with your Casio calculator, you would go to the place, or if you have any calculator that you have, you go to the place where you would see HYP. So just look for your calculator, you see where HYP is written. So you press your HYP and you would see all your hyperbolic functions. So look for where there's HYP. For certain calculators, you would have to press Shift, then HYP before you get to your HYP. So press it, for your Casio calculator, you only use your HYP. So you get it, you go to number 4 and you see your hyperbolic sign. Just click on 4 and you press your 0 inside the bracket and you see that your answer will be equal to what? 0. And therefore, x is equal to 0. So that means the 0 of this function is what? 0. Normally, we divided by 2 here, so we are meant to divide the answer by 2. But 0 divided by 2 will also be what? 0. And therefore, the 0 of this function is what? 0. Now let us look at the singularities of a function. So what is the singularity of a function? The singularity of a function are the values of x that makes a function undefined or invalid. Now, I said it from the beginning of this video that I would explain what the slight variation between the zeros and the singularities of a function are. The zeros of the function makes the entire function to be equal to 0, and while the singularities of a function makes the function to be what? Undefined or what? Invalid. So they are both zeros. At the end of the day, we equate the functions to be equal to 0. The same steps we use to find the zero of a function is the same step we use when finding the singularities of a function. But for the zeros of the function, it makes the entire function to be equal to 0. And for the singularities of a function, it makes the function to be what? Undefined or invalid. Let's take, for instance, if we have a function f of x, which is equal to 1 all over x, and you are asked to find the singularity of this function, what you do is you will equate this place to be equal to what? 0. Why are we equating the denominator to be equal to 0? Because when I have 1 divided by 0, it will be what? Undefined. On your calculator, you see it as what? Math error. If I have 2 divided by 0, math error. So even if you have 0 divided by 0, it becomes what? Undefined or invalid. What it means is whenever the denominator is 0, the entire function becomes undefined or what? Invalid. So in this case, the singularity of this function will just be x equal to 0. Now let's go back to what I spoke about when we were talking about singularities of the function. If you are given a rational function, that means a function in the form of what? Fraction. You are given a rational function, f of x, which is equal to what? P of x over q of x. We did this before. The values of x that makes the function q of x to be equal to 0 is the singularity of the function. So those values of x that makes the denominator to be equal to 0, those values are what? The singularity of that function. Not 0, but the values of x that makes the function to be equal to what? That makes the denominator to be equal to what? 0 is the singularity of the function. So now let us look at examples covering both the zeros of the function and also what? The singularities of a function. So now we have these examples to compute the zeros and the singularities of each of the following functions. So computing the zeros and the singularities of this function. Now start from the first one. That means for each function, we are finding the zeros and we're also finding what? The singularities. You see that we have mostly of what? Rational functions here. So in this case, we are asked to find the zeros of the function. To find the zeros of the function, what we do is we just find the values of x that makes what? The numerator to be equal to what? 0. So for question number 1, finding the zeros. So for zeros, we have x squared minus 25. So first thing we do is we equate it to be equal to what? 0. Next thing we can do is from here, to find the value of x, we can take x to the other side. So there are two ways we can do this. The first way we can do is we can carry x to the other side. We have x squared is equal to what? Positive 25. The square root both sides would have plus or minus here. This square will cancel out this, and x will be equal to square root of 25 is what? 5. So we have plus minus 5, which is x is equal to plus 5 or what? Negative 5. And therefore, the zero of the function of this function is positive 5 and negative 5. I say there's another way of doing this. We could use the difference of 2 squared to solve this. 25 can be written as 5 squared. So we have x squared minus 5 squared equal to what? 0. We have not done anything to this. Now, based on the difference of 2 squared, if I have a squared minus b squared, it is what? A minus b and what? A plus b. So we can do this, we would have x minus 5 and what? X plus 5 all equal to what? 0. And from here you can see that x would be equal to what? Positive 5 or what? Negative 5. And that's what we did here. So you could use this to get it and you can use this to get it. It's still the same procedure. Now, For the second question, we would have to solve here. To get the, sorry, we are not done with this. So we just found the zeros. Let's find the singularity of this function. To find the singularity of the function here, find the singularity of the function, we have to equate or find the values of x that makes the function, the function on the denominator to be equal to what? 0. So we'll find the x squared minus 5x plus 6. It is the same procedure as finding the 0 of a function. So for this, we'll just equate it to be equal to what? 0. Now, since we have this, for this, we would have to find the sum of the roots and also the what? Product of the roots. So two numbers, when we multiply, we'll get positive 6. When we sum them up, we'll have negative 5. And those numbers will be negative 3 and what? Negative 2. So if you sum negative 3 and negative 2, you have a negative 5. If you multiply them, you have a positive 6. And therefore, the answer will just be positive 3 and what? Positive 2. Simple. So since we have this, the singularity of the function, is positive 3 and positive 2. That's all. So when you input it into this equation, you get your answer. Good. Or you input it into the function, you would see that the function becomes undefined or invalid. So let's move to question number 2. For question number 2, to find the 0 of the function, we would have 5x minus 3. We equate it to be what? 0. To solve for x, we have 5x is equal to negative 3 crosses over, it becomes what? A positive 3. Divide both sides by 5, and we have x to be equal to what? 3 over 5. And this is the 0 of the function. Now, to get the singularity of the function, we'd have x squared minus 2x minus 3 equated to be what? 0 also. The same process. Sum of the roots, product of the roots. So what will be the sum of the roots here and the product of the roots here? So those numbers will be what? Negative 3 and what? Positive 1. So negative 3 plus positive 1 would give me a negative 2. And negative 3 times a positive 1 will give me a negative 3. So you change the sign, you have a positive 3 and what? Negative 1. Therefore, the answer will be what? X will be equal to what? Positive 3, comma what? Negative 1. So this is the singularity of this function. Now to the third question, we have h of x to be equal to x squared plus 4x divided by, you have your polynomial function here because the highest power is greater than 2. Now, since we have a polynomial function here, what we are finding the 0 and also the singularity. So values of x that makes the numerator to be equal to 0 is the 0 of the function. So to find the 0, we write equation number 3. To find the zeros of the function, we have x squared plus 4x. You equate it to be equal to what? 0. So you can see we have x here, so we can factorize x. We have x plus what? 4 equal to 0. So when we carry x from here, we have one x left and we have no x here. So we have x to be equal to 0 or x plus 4 to be equal to what? 0. So x is equal to 0 or x is equal to what? Positive 4 crosses over, it becomes what? Negative 4. And the 0 of the function is x equals 0 and what? 4. Simple as this. So let's find the singularity of the function. Also, to find the singularity of the function is to find the values of x that makes the denominator to be equal to what? 0. So we'd have h of x, oh no, not h of x, sorry. Singularity. To find the singularity, we'd have x cubed plus 3x squared minus 10x. We equate it to be equal to what? 0. You see there's an x here, x here, x here. So we factorize x out. We have x. We have x squared now. Plus, how many x left here will be what? 3x. And there will be no x here. So we have 10 equal to what? 0. So x will be equal to 0. Or, so we'd have three values of x that will make up the singularity of this function. So since we have found the first value of x, comma, so let us find the values of x from here. So we have a quadratic function now. So since we have a quadratic function, we can equate it to be 0. Now we have this quadratic function equating it to be 0 now. To do this, sum of the roots, product of the roots. So two numbers when we multiply, we get a negative 10, and when we sum them up, we get a what? Positive 3. Those numbers would be positive 5 and what? Negative 2. So positive 5 plus negative 2 give me a positive 3. And positive 5 times negative 2 give me what? A negative 10. So change the signs, negative 5 and what? Positive 2. And we'll add them up here, negative 5, positive 2. So these are the singularities of the function. This is the singularity of the function. Now for this question, you would solve it and drop your answer in the comment section as you have understood this topic now. You can solve it and drop your answer in the comment section. I would really want to hear from you guys. And also, if you are enjoying this video, hit the like button, hit the subscribe button, and also share to your friends and what colleagues. So to the last question, which is question number 5, we have cot of x. So we are meant to find the zero of cot of x and the singularity of cot of x. Now cot of x from a trigonometric function is equal to 1 all over what? Tan of x. 1 all over tan of x. Now tan of x is equal to sine x all over what? Cos x. So tan x is equal to 1 over what? Sine x over cos x. So replacing this inside here, we can have that cot x is equal to 1 divided, because this is division sign, sine x over what? Cos x. Now if we have this, to change this division sign to multiplication sign, we'll carry the denominator to the numerator and carry the numerator back to the denominator. We'll have 1 multiply cos of x over what? Sine of x. And therefore, cot x would be equal to what? Cos x times 1 will give me what? A cos x. This is over 1 also. So sine x times 1 will give me what? Sine of x. And this is what? Your cot x. So now since your cot x is equal to cos of x over sine of x, we would have to find the zero of the function and also the singularity of the function. The zero of this function is the value of x that makes the numerator to be equal to what? 0. So therefore, we'll just find for zeros now, we have cos of x to be equal to what? 0. We have already done this. You check from the previous video, the previous example we did, we found the zero of this function. And the answer were what? 45 degree and what? 135 degree. So this is the answer to this. So let us find the singularity of the function. To find the singularity of the function, we just equate the denominator to be equal to what? 0. So to find the singularity of the function, we just equate what? The denominator to be equal to what? 0. So we have singularity now. We have sine of x equal to 0. So we have x. So for x now, we have sine inverse of what? 0. Now the sine inverse of 0 will be equal to what? 0. So let me check and confirm if I'm correct or not. So we have the sine inverse of 0 is 0. So the singularity of the function is what? 0. You could also add to this 0 degree, you see, or you can say 0. You could also add to this from your Cartesian plane, sine is here, positive here. So it is 180 minus theta. So therefore, 180 minus 0, which is your theta here, because this is the angle you first solved for. So 180 minus 0 is 180, so 180 degrees also. So these are the answers to all of these questions. If you really enjoyed this video, please hit the like button also, hit the subscribe button, and hit the share button. Thank you very much. If you have any question, you can also drop it down in the comment section. I'll see you guys in the next video.